Hi, good evening again. So I guess from the feedback that I have read, I see that some of you are having problems to understand this example 4 that we have discussed in the lecture, in the beginning of the lecture today. So I will go through this again and I hope that you can understand it better this time. So the example here says that for the limit as x approaches 5, for square root x minus 1 equal to 2, find a delta which is greater than 0 that works for epsilon greater than 1. That is, we want to find such number delta such that for all x, 0 is less than modulus x minus 5 less than delta. So it is 0 here because we have a condition where delta must be greater than 0. So by having this condition, it will implies that this also holds. Modulus square root x minus 1 minus 2 less than 1. So the first thing that we want to do in our first step is to find our delta. So we will start with our second statement here. We have square root x minus 1 minus 2 less than 1. So here we want to deduce x minus 5 from this one, okay? So we will move from here until here. Okay, so from here, using our knowledge on inequalities that we have covered before, you see that square root x minus 1 minus 2 is less than 1 and greater than negative 1. Okay, so now we want to try to isolate x to have only x here. So the first thing we do is we bring negative 2, we add 2 to both sides. So we have negative 1 plus 2, which is 1, less than square root x minus 1, less than 1 plus 2 is 3. So next we want to move the square root away. So we square both sides. We have 1 square equal to 1. Then we have x minus 1 and 3 square equal to 9. Next we want to make this one disappear. So we add 1 on both sides. We have 2 here, less than x, less than 9. So in the lecture, I told you to choose the maximum, right? So we see that our limit actually centered at x equal to 5. So the distance between 5 and 2 is 3. And the distance between 5 and 10 is 5. So we want to choose the minimum one. Okay, we have the minimum of 3 and 5 is equal to 3. So our delta will be 3. From here, we can conclude that for x minus 5 less than 3 greater than 0, we will have, or it implies that x minus 1 minus 2 less than 1. So some of you have asked me, why do we choose 3 instead of 5? So this can be seen in the graphical illustrations. Okay, you see here, now we have chose 3 here. So what if we chose 5? If we chose 5, this is our center 5, and then this is the distance 5 units. So this is the distance 5 units. From 5 to 0 and from 5 to 10. You see that when we choose 5, we have this point here inside our interval for delta, and this particular value of x corresponds to no value of y. You see, the lines end up here. There's no such line here. Okay, even if we consider x delta equal to 4, we will have to consider x equal to 1, which means that our values here for y, for x equal to 1, y will be 0. So this is invalid because we initially stated that epsilon equal to 1, but 2 minus 0, okay, 0 from this y here equal to 2, which is greater than our epsilon. I hope from this lecture, from this video, you can have a better understanding of how to find deltas algebraically from given epsilon. Thank you.